Greetings of the day. This is Divya MO from the Department of Computer Science PG, Kristu Jayanti College. I am working as an assistant professor. So today I'll be introducing you to the concepts of data structures. So we'll just see what is a data structure. We'll see the introductory portions related to data structures. So data structures are basically a place where we can put in our data properly, and that will help us to organize the data in a proper way. We can search for the required data. We can take off data from the data structures easily if it is structured properly. So normally it is as a data structure can be defined as a group of data elements which provides an efficient way of storing and organizing data in the computer so that it can be used efficiently. So we have so many examples. If we talk about data structures, we have already gone through arrays, linked list, stack, queues, etc. And we have various types of, based on the structure, we can say we have linear data structures as well as non-linear data structures. So data structures are normally used in almost every aspect of computer science because we have to store data. Take it for the example of computer security, or let it be the case of machine learning, let it be the case of big data analytics. Everywhere we will be dealing with data. So data structures are very relevant everywhere in computer science. Operating system, let it be compiler design, AI, graphics, let it be anything. So these are the main part. We can say these are the core part of any programming language or any core computing concepts, and which enables the programmers to handle the data. As I already mentioned, you can add data, you can retrieve the data, you can remove the unnecessary data in a very efficient way. And it plays a very vital role in enhancing the performance of the software or a program. As a main function of the software is to store or retrieve the user's data as fast as possible. So it's all about how the data structure is behaving, how it is optimized in its own way to store, retrieve and delete data wherever it is necessary. So basically data structures are, as I've already mentioned, organized data plus what all operations we can perform on the data structure. So you can see an example here where I have mentioned a small linear array where I'm storing characters, and you can see the memory locations mentioned on top, and the indexes are also mentioned. I hope you are familiar with the array concept. So each and we call it as a data structure where you can store elements of the same type. So here it is a character array. So you can see index 0, 1, 2, 3, 4 and so on like that. And you can see few characters are stored in the array and the memory locations also are mentioned above. So it is a particular way of organizing. So we have created a character array. We have organized the elements according to the memory locations. Accordingly, the memory locations and the indexes are mentioned in the figure. So moving on to the next one. So the representation of particular data structure in the main memory of the computer is called as a storage structure. The storage structure is a representation in our auxiliary memory is called as a file structure. And it is defined way as of storing and manipulating data in organized form so that it can be used efficiently. And there are mainly the following four specific things to be taken care: organization of the data, accessing methods, degree of associativity between the data one among the other, and the processing alternative for information. So basically you can say that the algorithm to store a new data, the way we retrieve the data from the data structure, and we delete the data from the data structure. So you have the algorithm to do all these things, plus your data structure will give you the program. And the data structure study is basically, that is the subject we have started off with. So it is a study that covers the following points: the amount of memory required to store your data, the amount of time required to process, and representation of data in the memory along with the operations performed on the data. So these four major criteria actually defines whether the data structure is efficient in your problem scenario or not. So we can see here in the diagram, you can see the broad categorization of the data structure, the built-in data structures as well as the user-defined data structure. So you can see here the built-in data structure for any programming language for that matter. You will have some built-in data structures available for use. For example, integer, float, characters, character data type, or you can have pointer data types. So these are the data structures which is built in which comes along with the programming language that can be available for use. So those are the category which falls under the category of built-in data structure. The next one is user-defined data structure. For example, now we have seen an example of an array where it is actually an array of character type. So you are using a combination of built-in as well as the user-defined form. So I am creating an array of type character. That means I am using the built-in data structure called character to create an array. So user-defined data structures are, maybe we can say some examples, mention some examples like array, lists, files, etc. So under array, all arrays, we have already seen the example, it's all linearly structured. It can be one-dimensional array or two-dimensional array. And when it comes to lists, under lists also you have few examples like stack and queue. All these are linear data structures. And when you come to non-linear data structure, you have trees and graphs and all those for that matter. So to conclude, we have just gone through what is the data structure, what are the basic objectives, how do we exactly generalize data structure, and the different types of data structures. And thank you so much for watching.